Hello friends, welcome back in VMware Cloud Foundation Deep Dive Webinar Series, Part 5, where we'll be discussing today about VMware Cloud Foundation Networking. Before we start, please don't forget to like, share, and comments against the video, and subscribe my channel and press the bell icon for the new upcoming exciting videos. For any feedback, you can write us on comments or you can write us mail on nextgencf@gmail.com. Well, as today we are on part 5, where is VMware Cloud Foundation Networking with NSX. We'll be talking about what are the key topics for this part and for these sessions are NSX Overview and Benefits. We'll be talking about the brief overview of NSX and its benefits, explain the virtual IP addressing, how do we access the NSX through the virtual IP, describe the logical switching and the multi-NIC design with VCF along with NSX, leaf and spine topology design. Then we're talking about the NSX Edge functions, describe the NSX deployment, how we can deploy NSX in VMware Cloud Foundation environment, the logical routing, talking about T0 and T1 gateway topology, designing NSX Edge node, describing about the routing protocols like BGP and OSPF and cluster design and the rack design. Then we're talking about, however, we'll be covering this little bit early under the Edge sections itself. Then application virtual networks, an important topic where application virtual network is primarily the mandate requirement, the environment where you are deploying the VA realize should altogether. So let's talk about NSX. What is NSX? So probably some of you have already heard about NSX. NSX delivered the software-defined networking. When we say the software-defined networking, the many networking aspects is its own software layer itself. Primarily, we talk about the switching, we talk about routing, we talk about the firewall, distributed firewall, or the gateway firewall, VPN, IPsec, uh, VPN topology, load balancing. So lot of use functions are available at the software defined layer within the NSX. So from architecture perspective, NSX is divided in multiple planes where we refer as management plane. Management plane primary, we refer as the NSX manager, where we are putting our inputs from the management console to NSX using the UI console, or maybe we are using the CLI console or API console of the NSX manager. So within management plane, we have the manager policies, management and policy manager, and the control plane. Control plane is taking care of all the controls and pushing the information to the local control planes of the transport node, where transport node we refer as kind of ESXi or the edge. So from deployment perspective, then next is data plane. Data plane is my ESXi host, my cloud gateway, my appliances where I'm putting the NSX directly to Windows VMs. These all are the data plane function. So where we can deploy NSX could be deployed the entire, kind of VCF environment. It is available at on-prem or it is available with any public cloud provider, kind of VMC on AWS, AVS, or GCV and other solutions. And what all other components within the VCF, your SDDC manager, VMware, vSphere, vSAN, Tanju, and ARIA should. That's we have already discussed a lot about all these components. So overall, NSX providing the networking to your virtual machines, to the Kubernetes environment, to the VMware Tanzu environment. Okay, so a lot of environment where NSX is kind of providing the kind of networking. Along with this, it providing the container plugin, especially where your application modernization need to be happen on VMware Tanzu or vSphere environment kind of. So moving ahead, if we'll see the overall advantages of NSX within VMware Cloud Foundation, NSX is providing us the overlay networking. When we talk about overlay, probably you have heard about underlay and overlay. Any traffic passing through the overlay, it's more secure as compared to the traffic with that we are moving through the underlay network. Encapsulated with Geneva encapsulation. Then it's provide gateway firewall function. We can protect any kind of communication that is moving outside of our data center or coming any ingress or outgress. We can put the firewall, distributed firewall. Any traffic is moving within the data center among multiple VMs or among multiple applications. Load balancing functionality, URL protection, protect application by built-in security, kind of distributed firewall, uh, threat prevention services. HTTC manager automates the deployment. When we say the automate of deployment, during the my NSX is automated deployment by using HTTC manager, or while where we are deploying the day zero deployment of the VCF environment. When I say day zero deployment, the management domain will get deployed, and during the management domain my NSX component will be deployed. And like if we are going to deploy kind of workload domain, so again for each workload domain, HDDC manager provide the automated functionality to deploy the NSX component, NSX across all the workload domains. Okay, so these are the primary advantages. The SDN services being provided by the NSX in the VCF environment. Those are primarily your switching, your routing, security perspective. Those are firewall, gateway firewall, distributed firewall, and load balancing services, URL filtering, and kind of threat prevention service. So lot of things are available within the software defined layer by your NSX. Well, how the NSX manager and how we can plane. So any user can access the NSX management plane or the NSX manager console access through UI, through REST API, or through the kind of CMP layer. Okay, and that can perform the functions, the NSX function through the management plane. Then this will push to the control plane. So in NSX manager, my management plane and control planes are together within a entire set of the appliances that we are going to deploy for NSX manager. So where you could see in management plane, we have two roles are inbuilt, the policy role, the manager role, and a control plane primarily works as controller role, which just take the information from the policy and management role and push it to the local control planes. When I say local control plane, my transport node, it could be my edge node, or it could be my physical ESXi node, maybe my KVM host. So these kind of information will be pushed by that to from the central control plane to local control plane. So deployment perspective, we always deploy the NSX in 3 NSX manager node for high availability and scalability perspective. Either we can go with one node of NSX, or we should go with the three nodes of NSX cluster. So where VCF mandatory requirement, not a mandatory requirement, is a recommended requirement. We should go with the from high availability and scalability perspective, we should go with the 3 node configuration in my VCF environment. As I said, it could be changed to one node, but we cannot deploy to two node ever, either one node or 3 node. 3 nodes, I would say. So cluster virtual IP, all 3 nodes build up a cluster altogether, and a virtual IP will be created. And kind of during the deployment, we have to give the details of all kind of, I would say, the FQDN detail of NSX Manager 1, FQDN detail of NSX Manager 2, NSX 3, and all three will work as a cluster. Then I have to assign a kind of VIP to virtual IP with the fully qualified domain name, so that and the user can access, whoever is the NSX admin, he would be accessing through the VIP, through the virtual interface IP address, through API or the GUI client interface to your NSX manager console after deployed. When we say the logical switches, what are the logical switches? Well, the logical switch, or we say the logical segments, are the same thing. So it's moreover the similar that we use the concept of port group in the distributed switches. So same way in NSX, we can create the logical switches. So under the logical switches, further we can connect our VM. So like for an example, a web segment. This is and a virtual network ID have been assigned to this segment. So this segment is a kind of logical switch where we could see the multiple virtual ports where my VMs will get connected. As I said, it's moreover similar the way you are deploying the port, you are configuring a port group in VDS and you are further assigning the VMs. Same way you are creating a logical switch and refer as logical segment as well. And under the logical segments, you are further connecting your virtual machines or maybe the containerized application. Same way you could see this is the segment and this is the segment ports. Okay, so this is also end of the day it's going to create under the VDS. Whatever the segment you will be creating in NSX, all would be visible within your VDS, which is where you can, you can whenever you are creating a virtual machines in your environment using the vCenter. So on the basis of desired where you want to connect, probably you could have the number of segments, so you can connect to the desired segment, and all the segments would be visible within your virtual distributed switches as well. So when we say segment profile, within segment we can configure the quality of service, IP discovery, spoof guard, switch security, MAC address management. Okay, so these all kind of policies we can configure with the segment level. Moving next, deployment of NSX in the VCF environment. So, as I said earlier, NSX for management domain will be built. All my NSX manager, the three managers, as I say, as per default architecture, for the management domain, they will be deployed during the bring up process itself. And for workload domain, any workload domain will be deployed with the help of SDDC manager. We have to install the we have to just download the install binary of NSX environment, and along with this vCenter, when we are going to provision a new workload domain. A creation of new workload domain means you are creating a new vCenter server and new NSX. However, it's a choice of design, it's a choice of deployment. If you want to share same NSX with another workload domain, that's also possible. Like if you are going to create another workload domain, let's suppose the workload domain 2, and you want to leverage existing NSX managers you can leverage, then you can deploy only new vCenter server. So the NSX construct could be shared among multiple workload domain as well. However, you cannot share the NSX that you have created for the management domain with your workload domains. It's not possible altogether. The NSX would be always separate for management. But yes, the NSX for multiple workload domain can be shared. It's a possible architecture. Okay. All right, so that's what it's saying. NSX Manager 3-node cluster deploy in management domain. That's come with the deployment process. NSX Manager nodes and workload domain vCenter instance as a compute manager. NSX Manager creates VLAN, overlay transport zone, host transport zones. Altogether, NSX Manager creates an uplink profile applied to the all the hosts. Those are part the transport node. Okay. So hope you are clear now, like the way how we do deploy the NSX. I'm repeating one more time. NSX for management domain will be deployed during the deployment time of management domain from the Cloud Builder appliance. However, the NSX Edge we have to deploy post deployment. Same way, when we are going to create a new workload domain, it will create new NSX construct along with your vCenter server. If you are creating another workload domain, either you can share the existing NSX, or you have to keep it separate for each workload domain. Okay, from the security perspective, if you want to keep the separate construct, that's also possible architecture. It's all matter like how you want to go. Well, about VDS, ESXi, all the ESXi host will be managed through the VDS, that we refer as virtual distributed switch. All the port groups will be available, kind of, as I said, the port group that you have created and also the segment that you have created in your NSX. Those all will be available in the distributed port group. When we say the physical NIC construct, how we wants to go, it's all matter like how and many physical NICs we want to use. We can go with the a bare minimum 2 physical NICs are required. If you want to go with 2 physical NIC or 4 physical NIC with single VDS configuration, you can go with that as well. Or if you want to make like you have 4 NICs, out of 2 NICs, you want to use 2 NICs to one VDS and 2 NICs to another VDS2 as well, where you are segregating your traffic as well. VDS2 will take care of vSAN part. Rest of the traffic will take care of this. Or if you want to go again with 4 NIC configuration with 2 VDS, VDS1 will take care of all the traffic, and VDS1, VDS2 will take care of overlay. I mean, it means to say that the old traffic management, vSAN, vMotion will be taken care by VDS1, whereas VDS2 will take care of overlay traffic. So it's all matter, and it's as per your design how you wants to go with your environment. Okay, so here you could see there is three 6 physical NICs per host I am considering. The VDS1 I am taking for management, these port group, VDS2 for the VM network, VDS3 for this. Okay. So it all matter, like either you can select through the deployment parameter workbook, or if you want to refer the JSON file deployment JSON instead of the deployment parameter workbook in your cloud builder appliance during the management domain creation. Actually, here I'm talking about management domain. So it all matter like how you wants to go. If I would show you, just allow me the time. Let me just come out and just go inside the deployment parameter sheet of VCF. There I can show you how this could be selected. So probably you can see on my screen, there is a tab of network profile. So under this network profile section, one second, just one second. Hold. Here you could see profile one. A profile one could go with the VDS1 where 2 or 4 NICs can be utilized and all my traffic will be managed by the single VDS. If I'll go profile 2, there is a 4 NIC where VDS1 will take care of all respective traffic management, vMotion, host overlay, and kind of vMotion and all. Secondary VDS will take care of vSAN traffic. Also, I can choose profile 3. Under the profile 3, 4 NICs, 2 NICs will go VDS1, it will take care management, vMotion, vSAN, another traffic, and where this host overlay will be taken care by the secondary VDS. If we want to go beyond it, also we can go, but we cannot do more changes in the Excel beyond it. And for that, we have to use the JSON file. That probably you are aware in Cloud Builder, we can push the JSON file as well. Okay, and same way for the workload domain creation, beside the default configuration that we are seeing normally inside the deployment through the SDDC manager, uh, we can go for JSON based deployment through API. There we can configure the multiple NICs as per the environment requirement. Next, we are looking for leaf and spine architecture. So most of you are aware like what is leaf and spine architecture, but again I want to recall you. So for leaf and spine architecture, we keep layer 2 and layer 3 switch to the top of rack switch, and all the top of rack switch for the scalability and redundancy purpose, all the top of rack switch is being connected to the uh, to my spine switches. So this is how this architecture being created. Uh, Okay, this is 2 tier architecture as compared to 3 tier architecture, where all my kind of a proper load balancing across these spine switches. If I want to bring again new rack, and all the top of rack switches will be connected to the spine switches. Okay, and where this kind of rack where I am putting the edge, when I say edge, where I am putting my edge cluster, my edge nodes. Uh, Okay, that would be connected through the WAN. WAN means my traffic is going outside of the data center. Okay, let's talk about what is Edge. So NSX Edge provides several important functions within NSX itself. But yes, along with manager, we have to deploy Edge node separately. Okay, so serve as the resource for routing component. The main function of this is the Edge component putting the routing. Okay, providing the connectivity to external gateway, offering the various networking services such as NET, that we refer as network address translation, load balancing. Okay, terminate the overlay network uses separate routing tables, kind of two routing component, T0 gateway and T1 gateway. Okay, so and site to site VPN. So these all tasks. Beside, you will see like I am not seeing any firewall rules and all. That's the kind of routing, netting, load balancing. It's all being taken care of by the Edge component, where we deploy Edge. Edge could be a physical appliance, or Edge could be a VM, a virtual appliance. Okay, so within Edge, when we deploy the Edge appliances in my VCF environment for management domain and for workload domain, they have they have inbuilt logical component T0 and T1. T0 we refer as gateway router, where T0 is taking care of the data traffic is moving outside and inside, any kind of routing you are doing, data in and out, that we refer as north-south routing as well. And T1 primarily taking care of the routing within your data center. That's we refer as distributed router. Okay. So when we say the distributed router or T1, which is taking care of the routing, we refer as east-west routing as well, and the routing within your data center. Like for an example, you have one segment app, another segment, you have DB, another segment, you have web segment, and you want to perform the routing. So this all kind of routing being taken care of by your T1 component. So when we deploy any Edge environment, it deploy by default one T0 and one T1. And if you want to later want to create more T1 within Edge environment or more T0, you can create as per your design requirement and as per your environment requirement. So we again, VMware Cloud Foundation automate the deployment of Edge VMs, create configure Edge uplink profile, all the Edge segments, enable configure T0 with BGP configuration. BGP we refer as border gateway routing protocol. Okay, configure the initial T0 and T1. So a lot of automation, any kind of expansion and all. This all task being taken care by your SDDC manager, who will take care of it by your either it is your management domain or workload domain, as I described earlier. It's not part of day zero build during the build. Yes, but once, for example, once your management domain have deployed, it's deploy the NSX manager component. Those will take care of manager and controller both all together. Later on, through SDDC manager, you can deploy the edge nodes just by few clicking in your environment, just by few click within particular domain. Same way, if you have any workload domain and you want to deploy edge, yes, it will allow you through the SDDC manager, and you have to follow some general steps like cluster, their FQDN name, their T0 during the deployment. What is T0? What would be T1? What would be my edge uplink? So these all we have to, what all constructs, what all the prerequisites being required. We have to keep ready kind of FQDN, DNS record, DHCP, sorry, not for DHCP. DHCP could be available for assigning the IP pool, the overlay IPs to my edge nodes. So, I mean, the primary goal is to describe here, it's an automated process through SDDC manager. When we say prerequisite perspective, where you could see edge 1 VM, it required one management IP, it will require one uplink 1 and uplink 2 and edge tap IP addresses. Okay, so you could see here the edge tap IP address. So all these VLANs should be pre-configured. Wherever the tap IP address is assigning the tap IP, the tunnel endpoint interface IP, where we refer as edge. It could be define a NSX IP pool further, or we can deploy we can give an IP range to assign the tap IP addresses during the deployment of edge node. The uplink, the VLANs we are using for uplink 1 and uplink 2 should be routed with each other on the top of rack switches all together. Okay, so you could see in this example here we are deploying two edge VMs. So again, edge could be deployed as a standalone and a cluster way. So NSX Edge cluster where we can go bare minimum with two configuration in active state, or we can go with active and standby. So there is a lot of uh, kind of differences when we use active. When we say an active, so some of the services we can use only on stateless configuration, and when we use active standby, anyway it's all together working together, but some of the services could be configured in stateful mode. When we say stateful, kind of IPsec VPN kind of features that could be stateful, and in here in active state it would be an stateless configuration. When you say stateless configuration, any kind of gateway firewall you are configuring, you have to configure the same rule for inbound and outbound, where it will automatically read kind of in active standby. If you make some inbound role, whenever the traffic is moving outside, it will automatically read from the inbound role what are the policies being configured. So this is the difference. Wherever in active mode we can go minimum 2 to 10 nodes of deploying the edge appliances. In it, during the deployment perspective, it will show you the kind of, you can go with 2 nodes, later on you can expand or you can delete the environment. Yeah, also we have to keep in mind on the top of rack switch, wherever which in which rack we are putting the edge appliances, my BGP should be configured. Whatever the autonomous number you are using here, your autonomous number should be different. It could be 65002 something, and here on the top of rack I'm configuring 65 triple kind of 201. So this is something, this is the prerequisite before you are deploying the edge appliances. Okay, so edge cluster sample configuration, 2 uplinks per edge node. We need kind of 2 uplinks per edge node. Okay, and 2 taps per NSX edge node. Okay, a autonomous number should be different than the autonomous number we are using top of rack switch for configuring the border gateway routing protocol. When using deployment consideration, so management network, gateway network must be reachable from NSX host and NSX edge. And vSphere cluster where you deploy the edge appliance include the multiple hosts. All the traffic should be over L2 uniform network, and you cannot deploy edge cluster where a cluster is already being stretched. So these are number of considerations we have to keep in mind how to do that. So like as I said, how to deploy the edge cluster, it's pretty simple. Go to HDDC manager, select your cluster, go to action page, then you can add the edge cluster. Okay. Well, there are some setting when we are starting for deploying the edge cluster. We have to give name, the MTU size. Here is 9000. If you have configured 9000 at MTU for the fast data in and out speed, we have to keep in mind the switches where we connecting our ESXi host, where we deploy the edge nodes. The MTU value should be matched. ASN number should be different. These are the T0 these are the T0 detail. Then the value. These all are the kind of the passwords we are configuring. Okay, and in edge cluster setting, very important, like for which kind of environment we are putting. If we are putting AVN, probably you will size different size, you will find the different thing here. Custom Kubernetes workload, it's required the L size. Okay, and the routing mechanism, if you are to configure static routing, static route should be configured. If you are creating eBGP on the top of rack switch, already kind of BGP configuration should be available in the advance. Okay, so this is how we have to do selection for the edge deployment. Okay, either we are doing for the management domain or the workload domain. However, OSPF is also supported protocol for the routing, but it's important thing, OSPF is not integrated in HTTC manager. It is not support the AVN. People who ask the difference, why not OSPF is the recommended in kind of VCF environment, then these are the main caveats, or we could say the limitations with the OSPF. Okay, OSPF does not support it with the stretch cluster because it's an in boundary protocol. It cannot be in federated environment. AV uplink is not integrated with your kind of HTDC manager. Okay, so still, if you want to configure OSPF and you don't want to leverage kind of these functions altogether, you can configure OSPF routing as well with your edge nodes. For configuring the OSPF, go ahead and just have a look in the kind of KB article which is highlighted there. Okay. configure the page again, the page all parameters, kind of what would be the name, what would be gateway, what is the tap 1 IP, what is the tap 2 IP, what is uplink 1, uplink 2. Okay, so these all details we have to configure during the edge node deployment. Once edge node is successful, then it will show you the finish. Okay, then if you want to expand or you want to perform any kind of day to operations with your edge cluster, it's available in the particular domain. You will go kind of probably management domain, workload domain, whatever you are using. Go there under the edge cluster section, then you will find the expand the edge cluster if you want to add, shrink the edge cluster if you want to delete any existing edge nodes. So it's all, I mean, you can refer the given KB article if you wants to make any change in the existing edge cluster environment. Okay, so while we are putting the edge, there is two way of putting the edge. Either you are putting the edge appliances within the rack where my workload domain is being created, or you can put in separate. Okay, so if we are taking this architecture, wherever is my workload domain being deployed, so let us suppose this is my workload domain, first host, second host, third host, fourth host, fifth host, sixth host. This is my workload domain which is span across two racks, and I have put the two edge node. One is rack 1, one is in rack 2. Okay, so these are the edge available. So in this architecture, you could see the kind of design and ingress and outgress, ingress or egress traffic, the data center through every rack. Every rack will give data in or data out because it is just because of the distributed edge architecture. Okay, I mean multiple edge. Let us suppose I have another workload domain, and again there is one another edge node are available here. So maybe we have the another rack architecture where we are putting the another workload domain. Again, we have to deploy some edge nodes for the class for the new workload domain. So they have to travel kind of from the each rack in and out traffic. So this design is limited to where we are. I mean, it's create a complexity like tomorrow if this edge node moving from here to there, then I have to configure all the routings with the TORs available in this, or if we are moving from here to there. So this architecture is limited to less number of racks where the environment is not much bigger, but the environment is much bigger and is scalable where we want to use the kind of 20 rack scenario, or maybe more than that, or 10 rack scenario. Okay, so in that case the preferable topology or putting the rack, keep the separate edge racks, and wherever for all the workload domains, let us suppose this is my workload domain 1, I want to keep edge nodes, keep edge here. Same way, I have another workload domain being created maybe in another rack or maybe in same rack. So for these racks, create the edge nodes. Again, create the edge nodes here on the top of the ESXi host associated with your workload domain. I mean to say that in that way, your traffic would be easily. There would be one path of data in and out from your data center. That would be a kind of single rack or couple of racks only responsible for data in and out from your entire VCF environment, as compared to previous topology where we have seen like edge are deployed in a scattered way multiple places, where environment could be more complex as compared to the environment where we are putting the edge rack separately. Okay, so let us see how the routing functions will happen. So edge are my VM. These are my appliances has been deployed. So under each kind of these are my appliances, and inside these we create the logical construct that we refer as T0. T0 we refer as terminal 0 router. So terminal 0 tier 0 router, sorry, tier 0 router is responsible for performing the routing that traffic is moving in and out of your data center. We refer as north south routing as well. So each VM we have to configure the BGP configuration, BGP uplink, BGP neighbor. So you could see these are the two uplink. Out of one uplink will go to the router 1, another uplink will go to router 2. Same way one uplink go to here, same way another uplink, just for maintaining the redundancy. End of the day, these uplinks will be passing through your ESXi host distributed switches. Okay, and yes, this will work. So here we have to configure 4 times BGP pairing, 2 BGP pairing to this, 1 2 1 2, like that. Okay, just configure the T0 SR edge nodes. So there is two component is SR and DR. SR and DR. DR component is responsible for distributed routing and SR component responsible for the north-south routing. So any kind of routing we want to perform within the data center across multiple tiers of VM, we refer as tier 1 router. Tier 1 we refer as the distributed router. So these DR, these all segments routing across multiple segments is taken care by the tier 1 router. But if we want to configure the routing between tier 1 and another tier 1 router, means there is two tier 1 routers. Let us suppose this is my T0, and here is some of the segments being taken care by this T1, some of the segments being taken care by this T1. How they will talk with each other? So for that they have to go to DR component, SR DR to DR component for your T0 if you want to configure multiple. However, any routes from T0 to T1 is wants to go outside for your data center, data in and out. If you want to publish some kind of website that should be available globally, that's all functions being taken care by your T0 component. Okay, T0 router. So that's how routing being, we have to configure the routing. So under the T0, this could be the route, could be BGP or could be static routing. Okay, but within T0, like how this T0 is being presenting here, this T0 is presenting by one or two edge appliances. Okay, this T0 is a logical construct, a logical components being created under edge appliances. Okay, so this is my eBGP supported, but within my edge appliances there is configuration of what we refer as IBGP. Internal BGP protocol is by default configured. Okay, so it support 8-way ECMP. ECMP we refer as equal cost multipath routing. It support where we can, we can configure multiple. If we want to configure multiple edge nodes, then we can configure 8 edge nodes configuration. That's presenting still a single T0, but yes, the more scalable environment we will take, we have to configure the routing, uplink interface, routings and all. Okay, and BFD prefer as kind of a failover. If any of the component, any of the edge component will get failover within certain time, within certain milliseconds, all the responsibility will taken care by another. Okay, as we described in earlier videos, the edge appliance could be active. Whenever active, both appliances are working the routing functions, and when are it is these are active standby, it means that one time, however, they are syncing in the backend, but one time only one is working. If this is got failure, then this routing function will taken care by the another edge appliance. Okay, when we say ECMP, in ECMP is an active state. In ECMP, we need at least two edge appliance, or it could go up to 8. It could go up to 8 appliances. Okay, so where the routing will be distributed across all the edge appliances. Okay, all right. So this is how it's being described, that we have talked already about these slides, how the traffic will be managed. This is the same thing which we have discussed, the couple of slide before. This is the same thing. Okay, this is the same thing. Okay, so if it's a larger environment, we should keep in separate edge for my edge appliances. This is the one. And we have the smaller environment. For the smaller environment, this is okay. Like if you have 2 or 4 racks in your environment, that is fine. Edge could be distributed across multiple racks. Okay, but if you have larger customer environment, the enterprise environment, there should be dedicated rack where my edge appliance will get deployed on the top of ESXi host. So those ESXi host we should keep dedicatedly into the rack where we booked it or we reserved it just for putting the edge appliances and all my management component. Okay, let's talk more about the application virtual network, where we discussed earlier. The application virtual network are the critical component, or we say the mandatory component for deploying the Virilize Shoot Lifecycle Manager. Okay, so all my Virilize Shoot Life, not only Virilize Shoot Lifecycle Manager, entire Virilize suite, along with VRA, VROPS, Whirly, workspace one access. So now we refer as ARIA shoot. We realize shoot is now ARIA shoot. So the kind of environment we want to deploy with ARIA shoot and its component, and same way for, I mean, either we realize shoot is the same thing and end of the day. So for that, AVN is the mandatory construct. So AVN could be only created post deployment of AVN could be created the post deployment of NSX bring up process, and all my edge cluster should be deployed first. Then only we can deploy the AVN. AVNs are nothing, just a kind of the logical segments you typically create in your NSX. So these all are the primary things we have to keep: two NSX segments for the realized shoot solution or ARIA shoot solutions. One is the cross region, and another is the regional, or we refer as local region or the cross region. Okay, local instance or cross region instance management, cross region. Okay, so two types of AVN we have to configure, to deploying the realized shoot environment. Okay. So why the AVNR? The software-defined network topology. Software-defined network topology for applications in VMware Cloud Foundation, NSX Edge for load balancing. Typically, we use, okay, all my edge will work as a kind of load balancing, because some of the component of Virilize will require the NSX load balancing services. Simplified data mobility across the site, improved security, okay, and easily deployed through SDDC manager or API interface. Okay. So when we say two types of AVN, AVN could be the cross instance NSX segment and local instance NSX segment. So the important thing we have to understand where we should use the local instance. The local instance segment is for local instance realized shoot component. When we say the what are the uh, local instance realized shoot component. So if I would say this is my local instance NSX segment, or I will say this is the local instance AVN. Better to say it here now is local instance AVN now. Okay. And this is cross instance AVN. Now let's understand where we should use the local one and where we should use the cross region, okay, or X region. Sometimes we say X region as well. So the local region AVN, the preferable thing here just for the local component of realize shoot. What are the local component of realize shoot? It is your realize shoot lifecycle manager that we deploy locally for each VCF instance, and the local workspace one, or we refer as the standalone workspace one, or any kind of proxy or the collector we are creating for the VROPs proxy we refer as, or VROPs collector we refer as. So these will go for the regional AVN or local region AVN, which all components will be around the cross region AVN, or we refer it X region AVN as well. Or okay, so my VRLCM or ARIA shoot lifecycle manager. Okay, ARIA shoot lifecycle manager or VRLCM will be the part of cross region AVN. My VRA, all my VRA clustered environment would be the part of will be connected to the cross region AVN. VRA, VROps or ARIA operations, that will be part of cross region. And the clustered workspace one, the clustered workspace one access will be the part of cross region AVN. Okay, that's the important thing. I'm repeating it again. Who will be the part of the regional AVN, we realize login site or ARIA operations for log, I could say, and the and the standalone workspace one access, and the VROPs proxy and VROPs collector. Who would the component which will be connected to the cross region AVN, VRLCM or ARIA shoot lifecycle manager, ARIA shoot automation, or we refer as we realize automation, we realize operations for monitor or ARIA shoot for monitor, and the clustered workspace one. Why these are on cross region AVN? Region is being all these component we need to protect whenever any site will go to failure. However, these components are locally for each VCF instance. That's why we have to keep it them in the cross region AVN. Okay. So how you will be adding the AVNs is pretty straightforward way. Like first thing is where we should create AVN. AVN could be only created in management domain because all my realize should component part of management domain. AVN is not part of any of the VI workload domain. Okay. When I say VI workload domain, the workload domains you are creating for your VMs and workload. Okay. So as I said, the prerequisites could be NSX would be there, my edge should be deployed there. Then you will find the tab of add AVNs. Under the add AVN sections, when you will start, it will automatically ask you for the X region or the local AVN instance and the cross region AVN instance that you have to you have to give all the details. Further, the two types of AVN you can create, overlay back and VLAN back. When we say the overlay back, so it's a layer 2 traffic that follow the GNAV encapsulation, and VLAN back that prefer that is your kind of VLAN based traffic typically. Okay, but still whatever we wants to use is still there is two category. One under each there would be one regional, one cross region. Regional I refer as local and cross region AVN I'm referring for the same way here. Okay, but the preference to go with the just for more security purpose overlay backed NSX segments or NSX AVNs. Configuration support edge cluster that I tell one pair of AVN is required. AVN restrictions. Once AVN are deployed, edge clusters cannot be extended across multiple vSphere clusters. Okay, you cannot modify or delete AVN through the VMware cloud or delete AVNs through the VMware Cloud Foundation. That would be the part of kind of your SDDC Manager console. And once it is created, you cannot modify or you cannot delete or you cannot recreate them. Okay. All right. So whenever it's just an example here, I'm showing you like if you are deploying the ARIA Shoot Lifecycle Manager, during the ARIA Shoot Lifecycle Manager, it will ask you kind of the application virtual network. Probably you could see here application virtual network. And what is being here? XRG, MRG1 a segment, which means this is the cross region. Okay. So as I said, like ARIA Shoot Lifecycle Manager, realize Shoot Lifecycle Manager would be the part of cross region segment. Okay. So when we are deploying kind of Tanju environment for NSX, create all DNS environment inventory and deploy your NSX Edge cluster as per the recommendations for your Tanju cluster. Okay, Tanju could be deployed within management as well. Okay, so the keep only the thing here, the size of NSX cluster. Okay, so what all things we have discussed so far: NSX overview benefit, the VWIP, the logical switching, how the multi-NIC designs, how leaf and spine, what are the physical topologies with NSX, how the routings being happen. Okay, and T0, T1 topologies, node designs, difference between BGP, OSPF we talked about, application virtual network, how the networks being given over the kind of what is the normal things where we deploy the uh, Tangi Kubernetes environment, only the edge should be deployed. Okay. Especially I want to come back on AVN part, rest of the thing you should be okay. So when we say the regional AVN, within regional AVN, which all components I can connect? I can connect the VRLI, we refer as ARIA, we realize login site. We can connect the standalone workspace one access, and we can connect the VROPS collector or VROPS proxy, the same thing. Okay, just for collecting the data. When we refer as XRG, cross region AVN, in cross region AVN we connect all kind of ARIA Shoot Lifecycle Manager or Virilize Shoot Lifecycle Manager, same thing. VRLCM suite. Then we just deploy VRA with the cross region. We deploy VROPs with cross region. We deploy clustered workspace one access with XRG segment or XRG AVN. Okay, that's the important thing we have to keep in mind. Why these are in the cross region? Reason is being when we are deploying the multi-instance of VCF, like VCF1 or VCF2, this cross-region segment will be associated with your kind of T1 router, which is visible uh, across both the VCF instances. Then when we are doing failover, all my IP schema will be available even after failover. Why we don't want to protect all these components? Because these are locally deployed in these VCF instances. So we don't need to protect. We need to only protect these components any side of failure, your lifecycle manager, your operations, your automation, and your clustered workspace one access. Okay. Yeah, that's it for this module. Hope you have liked this video, and thank you very much for your passion. Thank you very much for listening me. Uh, don't forget to like, comment, share, and subscribe, and press the bell icon for more exciting videos. Thank you very much. Have a nice day ahead. Stay tuned with us. We are coming with more exciting videos. Thank you again.